Okay, over here to the right, we have the graph of the original function, which is 7x to the 2/5 minus 2x to the 7/5. These g of x, h of x, f prime of x, f double prime of x, those will come into play on subsequent whiteboards. But if you want to find the first derivative of f, here's what you might jot down on your scrap paper, or you might be able to do it mentally. So we'll take this 2/5 times the 7, reduce the exponent by 1, minus 2 times this exponent, reduce that exponent by 1. And this is what you end up getting. So that's your definition of f prime. To find out where we might have relative maximums or minimums, we want to know when does the first derivative equal 0, or when is it undefined. Those are called critical numbers. So to solve this equation, we want to multiply every term by this denominator right here, making note of the fact that x cannot be equal to 0. So that's why I have this little x right here when I'm applying the first derivative test. But if I multiply every term by 5x to the 3/5, this is what I get. So x equals 1. And that's what we have here. Here's where we prove that fact. First derivative test, the sign of f prime determines whether f is increasing or decreasing. So if I pick a number to the left of 0, because the 0 is a critical number, even though the derivative is not defined at that point, we get negative 28/5. And so this first derivative is negative everywhere to the left of 0, so the function is decreasing. You can see that's the case over here. Then when we get to the right of 0, but to the left of 1, f prime of 1/2 is a positive number, 2.12, so the original function is increasing. To the right of 1, like f prime of 2 is negative, the original function is decreasing, so there's your relative maximum at 1, f of 1. And that'll be this point right here, 1, 5. Notice that this point right here is not really a relative minimum. Well, I guess you could call it a relative minimum, but the first derivative is not defined there. Okay. Now, board 2. How do we find the second derivative? Well, if I go back to board 1, it's the same idea. We'll take this first derivative, take the derivative of the first derivative. We'll write this as x to the minus 3/5. So we'll be taking minus 3/5 times 14/5. That gives us minus 42/25, reduce the exponent by 1, etc. Okay, so there's the second derivative. We want to know when does that equal 0. Same deal. We'll multiply every term by the LCD, which is 25x to the 8/5. I multiply it times this term. These cancel out. When I multiply it times these terms, the second term, the 25s cancel out, but I get x to the 5/5 over x. And x equals negative 3/2 is when the second derivative is equal to 0. And so that's a possible point of inflection. We also have second derivative undefined when x is 0. So f double prime to the left of negative 1.5 is positive, concave upward, think smiley face, positive. To the between negative 1.5 and 0, the second derivative is negative, think a frown. And to the right of 0, also negative, concave downward. So here is a point of inflection at negative 1.5. That's the x-coordinate of the point of inflection. And that's kind of hard to see here, but this curve is kind of concave upward right there, and then at that point it switches to concave downward, and it stays concave downward even to the right of 0. Okay, on board 3, finding the intercepts, we want to know when does the first function, what is f of 0 to get the y-intercept? Well, that's just 0. And then you might notice at 0, 0, that could also be considered an x-intercept. Another way to find the x-intercepts is to say, when does the original function equal 0? You can solve this by factoring out an x to the 2/5 leaves 7 minus 2x. Either that equals 0 or x to the 2/5 equals 0. So there's one of the x-intercepts, which we already had identified, or x equals 7/2. That's this guy right here. Okay, that's the answers to your problems. Now on board 4, I'm showing you on Desmos how you can confirm your answers. If you enter the original function up here as identified, and then you enter g of x or use some other letter as the derivative, and then you type f prime of x, these graphs should match up. And that's a way to check your answer on Desmos. Even for the second derivative, h of x is the second derivative, f double prime of x is the second derivative. The graphs better match or you did something wrong here. Okay, there you go. Hope that helped. If you have any questions, post a comment.